Hi there, and welcome back to ADES Workshop. And as you can see, the favourite green jumper with the holes in has come out to play again. And you will notice I've had a haircut. We've had a bit of a period of nice weather here in Wales for the last week or so, sunshine and all the rest, which has allowed me to do a lot more stuff outside of the workshop, finishing off bits of the decking, painting the house, that sort of thing. So that's why I haven't been putting out so many videos lately, because the weather's been so nice and it's given me the opportunity after what's been a bit of a wet winter, but given me the opportunity to be able to get outside and do all the odd jobs. And plus, the missus was moaning for me to finish it, so I thought I'd better get on with it. Anyway, so that's why I haven't been about in the last week or so. While I was doing my sort of building works and what have you, my old cordless drill, which I've had for, yeah, probably 3 years or so now, finally gave up the ghost. The trigger went on it, and I took it all apart, had a look, and it was on its last legs. The chuck was getting worn. It did have a Jacob's chuck on it, but it was time for a new one. So I went out and got myself a DeWalt brushless one. Nice bit of kit. I mean, I'm not particularly a DeWalt fan. I prefer the Makita stuff really, but this was the right price, the right offer, you know, at the right time. So yeah, got myself a new drill, so I managed to do some of that work outside. Anyway, a few things going on today. I'll show you a bit of what I've been doing, you know, outside. But I've been asked a question by a few of my subscribers now about how to set up for turning angles on the lathe. Now, as we all know, there's several ways of turning angles, you know, offsetting the tailstock, using the compound, taper turning attachment if you happen to have one on your lathe, or, you know, angled form tools, that sort of thing. But this is going to be predominantly about setting up angles using the compound slide, and how you would set up an angle and use a clock to correct yourself or check yourself to see if you are at that specific angle that you want. Because as we all know, the little angle gauges on compound slides aren't that accurate, but you know, they get you in the ballpark. But you know, you could be half a degree, quarter of a degree out quite easily on them. So we'll show you how that is set up. And a little teaser, I've got some material here on the bench. I've sort of had to buy one piece in, but the rest of it was what I had lying around for a new project that I'm going to start. So I'm not going to tell you what it is, but I will show you my sort of materials list, and let's see what sort of guesses we get as to what I'm going to make next. So anyway, we'll carry on with that. So as you can see, we've started to get some hanging baskets and flowers on the go. The back of the house is now all painted, and yeah, we're just starting to get summery, so to speak, although today isn't a particularly nice day. We had hailstones a few minutes ago. We got an outside power supply on the decking. I need to put another clip in that wire. It's decided it's going to bend in the middle through, so I think another one just to keep it straight and looking nice. But that's that lead going down is actually the power supply to the workshop, but it's all been sort of revamped and renewed, and we've got a couple of well, let me just, it's a complete sort of waterproof sockets, that sort of thing. I think it's IP66 rating, so it can be, you could even put a pressure washer on this thing and it won't leak. Got a new hose pipe. I haven't got an outside tap, but it simply feeds through the window and goes onto the kitchen tap. But that's a bit handy on the decking here. And again, on the decking, as you can see, got the flowers underway, and you know, a few pots with flowers in it, you know, just to make a start, so to speak. So setting up the compound slide for angles, and I'm sure you're all aware, when it's straight like this at 90 degrees to the carriage, any movement you put on here would turn a parallel, as long as you clocked it into parallel, as it were. But typically, if you're turning an angle on a part, excuse me, you would turn it from the small end at the tailstock up to the large size at the headstock end, and your angle would be swiveled over in this direction. Now, typically you would say, okay, that would be an angle of 15 degrees, and obviously that would turn 15 degrees on either side, and that would give you an included angle of 30 degrees. So it would be 30 degrees if you measured across the outsides, but from its center line it would be 15 degrees, so to speak. Now typically that would be the way that you would describe the taper. You would say it was a 15 degree angle although the included angle either side would be 30 degrees. So if I say something's 15 degrees, we're talking about just one side. So the triangle here between parallel and the angle of the compound, the angle here would be 15 degrees. Set something up here to make it easier to explain, and we will have some drawings a bit later on, or my old rough sketches as they normally are. So I've got a fixed centre MT2 in the tailstock. Well, I will have if I wind it forward enough. There we go. And I've still got my head protector on, just make sure my tube is clean. And I've got an MT3 there up in the headstock. Now I have this bar here, which is a test bar. I don't use it. I've been tempted a few times to chop a bit off when I wanted material, but it's centre drilled. It's a piece of, oh, what is it? It's 20 mil, it could be 18 mil, 25, it doesn't matter, but it's a piece of silver steel, or drill rod as it's often known, and it's ground to a specific size on the outside. In fact, it's got a bit of rust on. I might need to have to give it a polish. So what I've done with this is clock the end up very accurately. Now thankfully this will fit up the tunnel of the lathe, so I clocked the end up perfectly. I centre drilled it, and then I machined a rough 60 degree angle, or 30 degree one side should I say, in there, machined it while it was running true. Then I flipped it round and did exactly the same on the other end. And what that means is I can put this bar, and it's probably about as long as I can get away with in this lathe. I think it's 12 inches long typically, and that gives me a bar that runs perfectly on centre to the axis of the lathe. So if I want to set an angle, I can measure in relation to 0 degrees. I can measure a distance of difference over a set distance with the compound slide. So I'll get a little sketch up and I'll show you what my formula is for working out on whatever angle. And it doesn't matter whether you're working in metric or imperial, the formula stays the same. So as it stands, that is my triangle. Big letter B here is whatever angle I decide I'm going to set up. So say I wanted 10 degrees, that would be 10. So big B would be 10. So in my formula, the sine of 10, the distance I'm going to wind the compound along over my measurement area is going to be small a, which is here, and I'm going to, let's say 25 millimeters, so I'm going to measure a lot across 25 millimeters. Then I will know from this formula, I can work it out what little b would be, or what would the deviation be on my DTI. When I wind along 25 mil, how much should the DTI go out by, would be the small letter b. And then I would know that when I've got that reading correct, that deviation of the DTI, that my angle is exactly, or near as damn it, my theoretical angle of the angle at B. Okay, so yeah, I'll just bring that in a bit more. So there is my formula. The sine of the angle equals the opposite over the hypotenuse. Yeah, this would be in the hypotenuse of the triangle. Normally this would be drawn the other way up. So yeah, the angle, the opposite, the adjacent, the hypotenuse. That's the normal way of showing it. But I've drawn it so that it actually replicates the shape we've got here. So the sine of the angle equals that distance divided by 25, in this case millimeters. I've got a metric DTI, so I will know what that figure is. So let's just put a few figures in here, and I shall do that now. So I've decided on a theoretical 10 degrees. So the sine of 10 degrees equals b, that length, divided by 25. So if I look at the sine of 10 degrees and multiply it by 25, that will give me b. So I'll do that next. So most people would just use a calculator or a mobile phone for this, but I do have a sine table in my good old trusty Zeus book. And sine of 10 degrees is 0.17364. So 0.17364 times 25 equals what b will be. So I can't do that in my head, so now I will get my mobile phone out. Okay, so my final answer came to 4.341. Now that's millimeters. if, for instance, I had a imperial lathe and my lead screws were measuring in imperial, I could simply say, okay, A equals 1 inch, say for instance. So if that was 1 inch, yeah, it would be 0.17364 times 1 equals, and that would be, my answer would actually be 0.17364. That would be the answer to the equation. If I was going to measure over half an inch, it would be 0.17364 times 0.5, and that would give me sort of half of that figure. What is that, about 80 something, 85, something like that, 1,000, something like that, you know, if I was measuring over a smaller distance. So yeah, the only thing you need to do, whatever that figure is, in a nice whole number you'd normally use, like in this case I'm using millimeters because I've got a metric clock. So I've gone for 25 millimeters as the distance I'm going to wind the cross light, and then I should get a deviation in the clock of 4.341 millimeters. So I've wound my clock in. It's 10 turns 10 millimeter clock. I wound it in 8 mil, maybe a little bit more than 8 mil, so that as I wind the compound across 25 mil and the clock comes away, it's still going to be, you know, it's no bother of it coming away from the test bar. Now, with this being a test bar, it could just be a piece of turned steel that you've just machined or what have you. As long as you know it's parallel, no problem at all. It could be a bar you've machined in the 3-jaw with a center in the end of it, you know, and then you've machined it once the center is in to give you a true parallel. As long as you measure at either end to make sure that it's that it is parallel and you haven't got any offset in your tailstock, happy days. So back to the plan. If I wind along in this direction using my compound, it's a metric compound, so 25 revolutions of the handle. I've got it set on 0 now. I'm looking for that clock to do 4 turns, and then 4.341 millimeters I'm looking for. So let's give it a whirl. So there's 1 turn, and you can see it's going already. 2, 3, 4. That's 5 turns of my compound, and you can see I've done 1 rev, nearly a millimeter. 1, 2, 3, 4. That's 10 turns, and I've nearly done 2 millimeters. 1, 2, 3, 4, 5, 6, that's 3 mil, 7, 8, 9, 10. So I've travelled 20 millimeters in this direction, and I've done 3.8 millimeters. So there's another 1, and I'm on 4 millimeters. 2, 3, 4, 5. So I've gone 25 millimeters with a compound, and I've travelled 4.85. Now, what that tells me is that as I was looking for 10 degrees, my angle is actually grown by more than the 4.31, so that my angle is greater than 10 degrees. And how much have I gone? 4.567, 4.7, 5, 6, 4.7, 4.75. So I've gone about 12 thousandths, or about 0.3 more than I should have, near as down, 0.3, 0.4 more than it's travelled. So I need to loosen my compound off, tap it to a more acute angle, just a little bit. I'll probably do it in the position where I am now, and maybe tap it 0.2, something like that on the clock. Then I'll go back to my starting position and measure again. So I've just loosened off my lock. If I go back to somewhere around there, Just tighten my lock back again. Obviously that will have changed the starting point as well. So now I just wind back the full 25 turns, set up the 0 again, and we'll have another inspect. So I wound back again the 25mm, reset the clock to 0 as my starting point, and I'm now going to wind forward 25 turns again and see what my reading is this time. So I'll just make a start. 1, 2, 3, 4. I'll bring you back when I've done 25. 20 revolutions, and we're coming up to the 4mm of travel. So 21, that's just coming up to 4. 22, 4 and a bit. 23, 24, 25. Okay, so I've gone 25mm, and this time I've travelled 4.7. So my knock last time wasn't quite enough. I think this time I'll knock it back till it goes to about 60 on my clock. Just loosen off the what's it, give it a little tap. There we go. I'll just nip it off there, reset, and do it all again. What I will do is, just because I've been altering the angle of the compound, I'll just make sure that my clock is still nice and square. It's not that fussy, but I will try and keep it nice and square all the time, because as I'm turning the angle, obviously the barrel of the clock is altering in relation to the squareness. So yeah, I'm all squared up. I've set back to where I was back at the beginning, 25 back. I'll wind it 25 turns. We'll see where we end up this time. So I've set it all up again now. We're going to have another test. Now, one thing I didn't mention, I'm winding this 25 turns up along here. That I just decided to measure along a 25mm length. You could, for getting it somewhere near or roughly right to start with, only turn it 10 turns. And obviously, if this A was 10, you'd then have sine 10 degrees, which is 0.17364, times 10, which would be 1.7364. would be my figure. So I could, as a shortcut, just wind along 10 turns, and I'd be looking for 1.736mm. So yeah, that you can save yourself a bit of setup time. So I'll basically go 1, 2, 3, 4, 5, 6, 7. We've already done 1 revolution. 8, 9, 10. And as you can see, I've done 1.9, so I know I still need to come back a little bit, and I've only got to wind 10 turns, and it just saves a bit of time until I get a reading somewhere near, and then I can measure over a longer distance at the end just to get it more accurate. So yeah, I pretty much need to just unnip my compound again. We'll try it to something like that. Wind back to 10 turns. 1, 2, 3, 4, 5, 6, 7, 8, 9, and that will be 10. Just reset my 0. Okay, 10 turns again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 turns. Well, we're going in the right direction, but nowhere nearby enough. But as you can see, just doing 10, makes it a lot more, a lot quicker to do. So I'm now on 1.85mm, and I was looking for 1.73. So yeah, we're getting down to the nitty gritty of it, but I'm saving myself a bit of time not having to wind, 50 revs, 25 back, 25 forwards. I think we'll do something similar again to the last time. May use this, I may not. So 10 turns from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're now on 1.83mm, and I want 1.73. So yeah, we're 0.1mm out over 10mm. But as you can imagine, we'd be 0.25 millimeters out over the 25, you know, that sort of thing. So yeah, I'll keep going, a little bit of adjustment. I mean, it seems like it's quite a long-winded way, but it doesn't take long. A few taps. You can tell if you've gone too far, because obviously your reading gets too big. And I'm just tapping that round a little bit in between each setup. Yeah, we're getting somewhere close now, over our 10 turns. So there we are, all set up on zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 turns. And I've got 1.567, 1.77, and I wanted 1.73. So yeah, we're creeping up on it. I'll get it as close as I can on this figure, then I'll go back to the 25 turns, and that'll show me a greater error if there is any greater error. But yeah, I mean, I'm getting there now. We're getting there now. 24, 25. So that was 4.12, 4.3, 4.34 and a bit. 4.34 and a bit. That is pretty much set up as near as I'm going to be able to do it, you know, with this method, over the 25 mil of travel down the A. My dimension should have been 4.341, and I'm at 4.34. Yeah, 4.34. Yeah. So yeah, that's how you would set up an absolute angle, or as near as you're going to get it, angle on your compound slide. And that then, if I were to turn a piece of bar, would give me an included angle of 20 degrees. Now, of course, the other side of the coin is when you've got a component with a taper on it. Say, for instance, you had a Morse Taper 3 sleeve. Now, I have shown how I set this up before. If you wanted to, for instance, machine a Morse Taper 2 or a Morse Taper 3, and you already had a sleeve, you could set the sleeve up, or a pre-existing component, whatever it might be, with that angle, with the desired angle you want to cut already on the part, and clock it into parallel. So we'll show you that next. So if I had no reference and I had no way of knowing what the taper was, I do, it's in Machinery's Handbook, it's easy to find online, but if I have no idea what taper this was, I know it's an MT3. But if I knew what taper it was, and I didn't have one, then I could set up my taper using the method we just described. But for this circumstance, hang on, I got my carriage locked, 2 seconds. Oh. What I would do here is very much the same. Let me just lock my carriage again, because I don't want the carriage moving, because that will change things. Okay, set a 0, and again, I would now wind my compound along back and forth until I got to a point where the needle didn't move at all. And that would tell me that my compound slide is parallel to the part. In fact, I'm going to have to move along a bit because my tailstock is hitting my, plenty of travel on my clock. Right, go from here somewhere. So yeah, I mean, I could set that on 0 there. Now obviously my compound is set on 10 degrees at the moment, so it's not going to read parallel. But yeah, I could start turning like 1, 2, 3. Now I can see my clock is dropping. Yeah. So I know that my compound is set far too far this way. It needs to stay more in contact. So I would simply loosen off my compound again. Bring him round. Now I know I'm miles out here, but I'm going to set it. Let me just be careful not to bottom my clock out. I'm going to set this by eye, it parallel to the face I can see there, or what appears by eye. Something like about that. Yeah. So let's start winding again. If I come back this way, what happens? So let's just get a 0. Well, as you can see, as I come back this way, my clock is rising. Yeah. So that tells me that I'm getting closer. So my guess is I've gone far too far the other way now. But let's just... Ooh, not that much. Daft bugger, right, something like that. There we are. Oh, hang on, let's just set a 0. Okay. So now as I wind along, I'm still dropping with my clock, nowhere near as much. So again, loosen off the compound, tap round a bit, and yeah, I mean sometimes you can get lucky and you can hit it on the second attempt, so to speak. Let me just put the clock parallel, that would help. Yeah, let's just see what happens now. Clock is still dropping, but not by anywhere near as much as it was. A bit more, and I'll bring you back after probably 2 or 3 more tries. You see, I'm not going mad with it. I could, you know, probably could have done double that, I would have thought, and still got there. I'm running out of travel on my what's it, but I'll bring you back when I've got it trued in. Okay, so we're getting pretty close now. Just wind it along. As you can see, I had an initial little jump when I started turning as I took the backlash out, but yeah, I mean, we are pretty much holding our 0 all the way along now over, well, that was probably about a 25mm length. So just to elaborate, I've drawn it a bit more conventionally at the end, how it would normally be. That's the shape of the triangle that we're forming. X here is our angle that we're looking for. So we were saying we were going to look for around number 10 degrees. This is the hypotenuse of the triangle, or what is going to be the compound slide travel, and we were going to use a figure of 25. O here is opposite the angle, which basically we are going to need to know that measurement, or how far the clock should move. And A is the adjacent here, which is the direction, or the 90-degree direction of travel, which is my test bar. And I've written them in here. X is the angle, O is the opposite, which is what we're looking for, the question mark. A is the adjacent, and H is the hypotenuse. Right. So the sine of the angle equals the opposite over the hypotenuse. It's part of the old soccer tour, or silly old Harry caught a haddock trawling off America, which is, we'll go into another day. So if that's the first part of the equation, therefore the sine of the angle times the hypotenuse will equal our mystery figure. So we decided on a 10-degree angle, theoretically 25mm travel along the hypotenuse would equal the 0. In this case, sine of 10 times the 25, 4.341 equals our mystery figure. So happy days. 4.341 would be how much we expect to see the clock move when we've set the compound at the correct angle and we traverse it 25mm, or as you saw me doing it, 25 turns of the handle. But again, I did take the shortcut to get it somewhere near by turning it 10 turns, and because we changed the figures, it was, instead of 0.17364 times 25, it was times 10, which obviously moved a decimal point, 1.736mm. So I did a bit of a shortcut, you know, to save winding back and forth quite so far, and just used the 25 turns right at the end to get my 4.341 of movement in the DTI. So anyway, this was for particularly, I think it was Dave Anderson was the guy who was asking. So Dave, I hope this helps you out, and if you need any further assistance, you can contact me back by email. I nearly forgot. I was going to reveal the materials and bits and bobs that I've got that I'm going to use for the next project. Now this is stuff I had in stock. So basically a couple of pieces of plate, a piece of 1/2 inch. I think this is, I think this is about 15 mil, this plate. I've got a deep groove bearing, a slug of aluminium, and I had to order it in because I didn't have anything big enough, but a piece of mild steel bar. I think that's 75 diameter, but yeah, it's not going to be that big in the end. It'll be machined down. But yeah, general idea that these are going to be the materials I use for the next project. Now I haven't got any designs for it. I'm going to make it up as I go along, usual story. So yeah, feel free to comment below if you can guess what it's going to be. Well, here we are, guys. How to set up angles on a compound slide. Now I'm sure it's going to be old hat to many of you, but to those who don't know and who haven't done it, and specifically as I've been asked to explain it, I hope this has helped. Anyway, thanks for watching, guys. Thank you all for subscribing. We're getting very close to 2,000 subscribers now. I'm overwhelmed with the sort of response I've had on the channel. Feel free to comment below if you can think what I'm going to be making next on the next project, and I'll try and do a decent sketch, and I'll probably put up a still at the end of this video with that formula showing the drawing. I might even do a better drawing, especially for the end clip. Anyway, again, thanks for watching, guys. Thanks for subscribing, and we'll see you all soon. Cheers now.